All right, our next lesson is going to be on solving 1 and 2 step equations. So we've got a few different properties we're going to talk about, and then we'll use those properties to actually solve equations. Okay, so to solve an equation, we're going to need to isolate the variable. Okay, and to do this, we use our properties of equality. And you can see that there are several ones that we're going to talk about. So the first one is the addition property of equality, and that says if an equation is true and the same number is added to each side of the equation, the resulting equivalent equation is also true. Okay, in a more mathy way of saying it, for any real numbers a, b, and c, if a is equal to b, then a plus c equals b plus c. Okay, if I start with 14 on each side of the equation, this is true. 14 is equal to 14. Okay, if I add the same number, so I add 3 to each side, then the resulting equation is also true. The subtraction property of equality is very similar. It says if an equation is true and the same number is subtracted from each side of the equation, then the resulting equivalent equation is also true. So for any real numbers a, b, and c, if a is equal to b, then a minus c equals b minus c. So this is the same thing, but just subtracting instead. So if I start off with a true statement, 18 is equal to 18. If I subtract the same amount from each side, I end up with another true statement. 11 is equal to 11. Multiplication property of equality says if an equation is true and each side of the equation is multiplied by the same non-zero number, meaning we're not multiplying by 0, the resulting equivalent equation is also true. So for any real numbers a, b, and c, where c is not equal to 0, if a is equal to b, then a times c is equal to b times c. So if I start with 5 on each side, 5 equals 5, I can multiply that times 4, and if I do it on both sides of the equation, the resulting equation is true. All right, and then lastly, the division property of equality. If an equation is true and each side of the equation is divided by the same non-zero number, the resulting equivalent equation is also true. For any real numbers a, b, and c, where c is not 0, if a is equal to b, then a divided by c equals b divided by c. So I'll start with negative 24 on both sides. And if I divide the left side by 8 and divide the right side by 8, I end up with the same result on both sides, another true statement. Okay, now these may seem kind of silly and almost pointless to a degree, because you're probably just thinking to yourself, this is all kind of, it's like common sense. It makes sense that if I add the same number to the same thing, it's going to work. But let's say instead of 14 equals 14 in this first one, if I had written it as 11 plus 3 equals 14, all right, all this still holds true. If I subtract that 3 from both sides, or I add 3 more to both sides, right, because this is the addition box that I'm writing in right now. So if I were to add 3 more to both sides, okay, 11 plus 3 is 14, plus 3 is 17. 14 plus 3 equals 17. It still works out like that. Okay, so really it's just important to make sure that we understand whatever I do on one side of the equation, I have to do on the other side. So we have the addition property of equality, the subtraction property of equality, multiplication property of equality, and division property of equality, all working together to make that a possibility, to make it so that no matter what I do on one side, if I do it on the other side, it will always end up being another true equation, another true statement. So we're going to rely on that down below to solve each of these one-step equations. Okay, and then we're also going to identify which property of equality we used. So for this first one, x plus 4 equals 20. I'm trying to isolate x, right? That was the very first blank that we filled in. I'm isolating the variable, so I'm trying to get x by itself. In order to do that, I'm going to get rid of this positive 4. How do I do that? By subtracting 4. But remember, based on that subtraction property of equality that we talked about up here, if I do that on one side, I need to do it on the other side in order to maintain a true equivalent equation throughout. So I'm going to subtract 4 on the right side as well. Doing that results in x equals 16. So we've solved for x. We've got it. We've isolated it. Now we need to identify what we just used. I already mentioned it. It was the subtraction property of equality. And you can abbreviate this stuff if you'd like. Subtraction. I'm just going to write prop of equality. Alright, our next one. We've got n over 7, or n divided by 7, equals 3. I want to undo whatever's being done to the variable to isolate it. So it's being divided by 7. So to get rid of division by 7, I'm going to multiply by 7 on both sides. So I'm multiplying that whole thing by 7. In fact, I don't like where that makes it look like I was only multiplying the bottom. We're really multiplying the top. So 7 and multiply by 7 over there. These 7s are going to cancel, and I'm left with n equals 21. So in that case, we multiplied. That is the multiplication property of equality. Our next one, we have negative 8 equals r minus 2. I'm trying to get r by itself. I need to add 2 to both sides. Negative 8 plus 2 is negative 6, and that's what r is equal to. So this was the addition property of equality. Moving on now to number 4. We have 0.5y equals negative 6.2. I need to get rid of that 0.5 that y is being multiplied by, so I'm going to divide by that. And again, whatever I do on one side, I must do on the other. This gives me y, and on the right side, negative 6.2. If I divide that by 0.5, divide that by a half, I end up with negative 12.4. This is an example of the division property of equality. Now this next one, well, even really with that last one, you could do it a couple different ways. For the next one here, I've got 5/6 times w equals 35. Whenever there's a fraction out in front, I like to multiply by the reciprocal in order to eliminate the fraction. You could divide by the fraction if you want. I just find it easier, typically, to multiply by the reciprocal. So I'm multiplying both sides by 6 over 5. Because the 6's will cancel, the 5's will cancel, and I'll just be left with w. But remember, if I multiply by 6/5 on one side, I have to multiply by 6/5 on the other. Alright, and 35 times 6/5, really if I want to, I can reduce these. 35 divided by 5 is 7. 5 divided by 5 is 1. I end up with 7 times 6 over 1. 7 times 6 is 42. Okay, otherwise you could do, what would you have? 210 over 5, which you divide that out, you get 42. Okay, so in this case, I multiplied on both sides, so that's the multiplication property of equality. But if you divided, you'd be using the, if you divided by the fraction, you'd be using the division property of equality. Alright, and this last one, I have negative 2/3 is equal to negative 1 3/8 k. Alright, so the first thing I'm going to do is I'm actually going to rewrite this. I don't like dealing with a mixed number here in front of k. I'm going to convert that into an improper fraction. So to do that, I multiply 1 times 8, gives me 8, and then I add that to the 3, that gives me 11. So this is going to be negative 11/8. So I'm just going to rewrite this. Negative 2/3 equals negative 11 over 8 times k. And again, when I have a fraction in front of my variable, when the coefficient is a fraction, I like to multiply by the reciprocal to get rid of it. In this case, I need negative 8/11. And the reason why I'm making it negative is because a negative times a negative will make a positive. Okay, so I'm going to do that on this side as well. I'm multiplying by negative 8/11. And on the left side, negative 8 times negative 2 is positive 16. And 11 times 3 is 33. So I have 16. Oops. Sorry about that. I have 16 over 33. And that's going to be equal to, the 8s will cancel, the 11s will cancel, and a negative times a negative is positive. So negative k times negative 1 is positive k. So in this case, once again, I used the multiplication property of equality. I don't know why that moved on me. Can I undo that? Let's see. There we go. It's back to where it belongs. Oh, no, maybe not. That's weird. There we go. Equality. Sorry about that. Alright, we're going to move on to the next section here. And we're going to start talking about multi-step equations. So here, a two-step equation is exactly what it sounds like. It's an equation that requires two steps. So to solve a two-step equation, you can think of it almost as a reverse order of operations. We talked about order of operations previously. And typically with order of operations, you'd multiply and divide first. But when you're solving a two-step equation, it's almost always going to be easier to mess around with addition and subtraction and then do the addition or the multiplication or division afterwards. Okay? So we'll typically, but not always, undo the adding and subtracting first. So again, whatever I do on one side of the equation, I have to do on the other. That's the whole idea of these properties of equality. So I'm trying to isolate x, or whatever my variable is. In the case of the first one here, number 7, it is x. We're trying to get x by itself. The way I think about these is what's being done to x. I see it's being multiplied by 11, and I see 4 is being subtracted from it. So again, it's almost always going to be easier to do it in the opposite order of operations. What does that mean? Instead of dividing by 11 first, I'm going to add the 4 to both sides first. Doing that gives me 11x equals 33. Now I can divide the 11 away, and doing that gives me x equals 3. Alright, and once again, we're identifying the properties of equality we used. We're using 2, so it's important to make sure that you denote both of them, and I'm going to write them in the order that I did them. So first we use the addition property of equality, and I'm not going to bother writing property of equality for all of these just because we already did it on the first example, and that's what we're using throughout all these are these properties of equalities. So we did addition, and then down here we did division. Okay, so we use the addition property of equality, then we use the division property of equality. This next example, negative m over 5 plus 6 is equal to 10. I'm going to start by subtracting 6 from both sides. I get negative m over 5 is equal to 4. And then I want to multiply by negative 5 on both sides. Why negative 5? I need to get rid of that negative that's out in front, and I need to get rid of this 5 that's in the bottom. So multiply times negative 5 on both sides, and we get m is equal to negative 20. So that was the subtraction property of equality, and then the multiplication property of equality. In number 9, I need to get rid of this -7 that's out in front. I'm going to add 7 to both sides. You can also think of it as subtracting -7 if you want to do that. The result ends up being the same. I just prefer to deal with less negatives. So I have 3/4 C is equal to -6. And then I'm going to multiply by the reciprocal again to get rid of these fractions. So the 3's cancel, the 4's cancel, and I'm left with C. And -6 times 4 over 3 is -24 thirds, which is equal to -8. So my first step was the addition property of equality, and then we used multiplication property of equality. For number 10, we've got 2 2/3 F minus 2/9 equals 1/3. So just like the example I did up above where I had a mixed number, I don't want to deal with that. I'm going to convert that into an improper fraction. So 2 times 3 gives me 6. I add that to 2, I get 8. So this is really 8/3 F. I'm going to rewrite this. 8/3 F minus 2/9 equals 1/3. I'm going to start by adding 2/9 to both sides. That gives me 8/3 F equals 1/3 plus 2/9. And really, if I want to, I can convert this 1/3 into 9ths as well. And write this as 8/3 F equals 3/9 plus 2/9, which I add those together to get 5/9. So now I have 8/3 F equals 5/9. I'm going to multiply by 3/8 on both sides. Doing that will get rid of the fraction that's in front of F. So the 8's cancel, the 3's cancel, I'm left with F. On the right side of my equation, 5 times 3 is 15. 9 times 8 is 72. And if I want, I can reduce that further. I can reduce that down to 5/24. I'm dividing each, the top and the bottom, by 3. So that was a lot of work there. We used the addition property of equality first, and then afterwards we used the multiplication property of equality. I've got one more here before we start to get into some word problems. So number 11, we've got r plus 9 divided by 12 is equal to -2. In this case, I'm going to start by doing something differently. Remember, back up above, I said that usually, typically, we're going to undo the addition and subtraction first. In this case, because the way this is set up, that the r plus 9 is being added together and put over 12, what I'm going to do is I'm going to get away from that, and I'm going to do the multiplication by 12 first to get rid of 12, and then I'll subtract afterwards. So you don't always undo the addition or subtraction first, just typically a lot of times you will. So, and it's not wrong, you could still do, you could subtract away 9/12 first if you want to, but that's, I just find it way more complicated. So I'm going to multiply by 12 on both sides. These guys will cancel. And I'm left with r plus 9 is equal to -24. Then I will subtract 9 from both sides to get r is equal to -33. So we use the multiplication property of equality, and then we use the subtraction property of equality. Okay, so we have some word problems here, and it says for the following, identify the unknown and assign a variable to it, then write and solve an equation. So when it says assign a variable, what that means is we're going to write what are known as let statements. That just means we're going to say let x equal, and then it'll represent whatever it is that we're trying to represent with the variable. And the variable doesn't have to be x, but pretty frequently you'll see that get used. So the first example I have here says Josh Allen has a total of 320 football cards to sign. He has signed 14 cards so far. How many football cards does Josh Allen have left to sign? So that last statement or question, how many football cards does Josh Allen have left to sign? That's telling us what we need to determine. Okay, that's what we're looking for. So that's what we're going to let our variable be. Whenever you see the question, that kind of gives away the variable. So I'm going to say let x equal, and it's going to be the number of football cards Josh Allen has left to sign. So I'm going to shorten that down to just number of cards left to sign. Okay, so now I'm going to look in here. We've got a total of 320. That's important. That means we're going to have something equals 320. And we're told that he has already signed 14 cards so far. So there's a couple different ways that I can think of this equation. The way that I'm going to approach it is 320 is the total. So I'm going to have 320 equals something. And that's going to be equal to the 14 that he's already signed, plus the number of cards that he has left to sign. Okay, and you could flip that order around. It could be 320 equals x plus 14. You could have x plus 14 equals 320. That doesn't matter. You just need the 14 and the x to be added together. All right, so that is our equation set up. And now we're going to solve it. So to get x by itself, to isolate it, I'm going to subtract 14 from both sides. And doing so leaves me with 306 is equal to x. All right, so our answer is that he still has 306 football cards left to sign. So 306 cards. Okay, the next one says a mechanic charges $30 just to look at a car. He charges $12.50 for each hour that he works on the car. If a customer's bill came to $80, how many hours did the mechanic spend working on the car? So again, our question, how many hours did the mechanic spend working on the car? That's what we're going to let our variable be. So we're going to let x equal number of hours spent looking at the car. All right, the customer's bill came to $80. That tells us we have a total of 80, so 80 equals something. It's equal to the $30 charge just to look, plus an additional $12.50 for each hour. Whenever you see each, that's telling you that you're multiplying by something. So they charge $30 regardless of whether they spend 5 minutes or 5 hours dealing with the car. Then on top of that, so we're adding, there's an additional $12.50 times the number of hours, which we have said we're going to let x represent. So this is a two-step equation. I'm going to start by subtracting the 30 from both sides, and we get 50 equals 1250x. Then I need to divide by 1250 on both sides to get x by itself. And doing that gives me x equals 4. So that means the mechanic spent 4 hours working on the car. All right, our last example like this, it says Jeff Skinner is buying a new hockey stick for the upcoming season that is on sale for 2/3 of the original price. After he uses a $25 gift certificate, the total cost before taxes is $115. What was the original cost of the hockey stick? Okay, so there's a couple things going on here, and it's a little tricky. All right, we got to pay close attention to this 2/3 of the original price and the fact that he's using a $25 gift certificate. So the thing that we're looking for is the original cost of the stick. So I'm going to say let x equal original cost. All right, and that's what we're looking for. So after he deals with the sale price and the gift certificate, the total is 115. Okay, so again, we're going to have 115 equals something. This 2/3 of the original price is important, as is the fact that he uses a $25 gift certificate. So if it's 2/3 of the original price, when you see the word of, that's really telling you multiplication. So it's 2/3 times our original price, which we have called x. So I can say 2/3 x. And then he also uses a $25 gift certificate. So using $25 gift certificate is going to reduce the cost by $25. So we subtract 25. Okay, now we're just solving for x. So I start off by adding 25 to both sides. That gives me 140 equals 2/3 x. And then to get rid of the 2/3, I multiply by the reciprocal. I multiply by 3/2 on both sides. And 3/2 times 140, or you can think of it as 1.5 times 140, or 1.5 times 140. That's going to be 140 plus 70, which is 210. So we get 210 equals x. So the original cost was $210. All right, and then the last part of this lesson, we have to write an equation for each of the following scenarios, and it says we do not need to solve, so we're just setting it up. So the first one says -4/11 of a number equals 13 1/3. So the first thing I'm going to do is I'm going to circle this equals here. That's telling me that this stuff here is on one side of the equal sign, and this stuff over here is on the other. Okay, so on the left side of the equal sign, we have -4/11 of a number. When I see a number, that's telling me x, and this of is telling me that I need to multiply. So I'm going to take -4/11 and multiply it times x. I can just write -4/11 x. Okay, that is equal to 13 1/3. So 13 1/3, just like that. That's all that I need. Next one says 3 less than 7 times a number equals 67. So I have equals 67 somewhere. 3 less than 7 times a number. Again, if it says a number, I don't know what that is. That's x. 7 times that means 7 times x. 3 less than means we're going to take 3, and this less than means I'm subtracting it from the 7 times x. So I have to have the 7x first, and then I'm going to subtract 3 away from that. So I end up with 7x minus 3 equals 67. I'm just going to move this over. 7x minus 3 equals 67. And then lastly, 1 subtracted from double a number is 17. Is another word that represents an equal sign. So we have something is being equal to 17. 1 subtracted from double a number. Double a number is 2x. If I subtract 1 from that, that's 2x minus 1. Alright, that's it for that. I do have some homework problems for you to try out. If you have any questions about them, feel free to email me. But they will be attached to this online.